Okay, this is a little review for the class, domain and range of this graph. Domain is as we look across, what are my x values? So if you can tell, you start at -2 and you're going to 3. The graph goes all the way there. So my domain is from -2 to 3. And why is there open, a regular parenthesis, but a bracket here? Because of the open circle and the closed circle. Now range is going up the graph. So as you go up the graph, as you can tell, the lowest value right there is at -1, and the highest point of the graph is at 3. So you're going from -1 to 3. They're both brackets because that's closed, and that point right there is closed. For this problem, let's look at the graph and see when is f of x equal to g of x. We're kind of solving it using graphing. It's called solving equations by graphing. So that's f and that's g. So when are they equal is what they're saying. What x value would make these equal? So you look at the graph, about where are they crossing? Well, when x is about -1. So around -1 would be your answer. The closest to that is where they cross, is what x value they cross at. It's a really cool way of solving equations. For this problem, if we look at this graph right here, I want to make a piecewise function for it. So I need to first think of the equation and the intervals. Now if it was me, I'd probably think of the intervals first. So for the first interval, we're looking for something less than, so let's look at the green graph right here. We have two graphs. We have a green graph and a red graph. The interval looks like where they change graphs is at 0. So for x values less than 0 is going to be the green graph, and for x values greater than or equal to 0 would be the red graph. So that's why we have this right here. Because we have to kind of look basically where the graph has a new line, and that is where your break is going to be. And then you got to figure out the equation of both lines. So for the green graph, you know your y-intercept is 3, and it has a slope of 3. So that's where 3x plus 3 comes from. For the red graph, I know my y-intercept 3, and it looks like the slope is down 1 over 2. So slope y-intercept of 3 and down 1 over 2. So hopefully you can tell that. This is the red graph equation, and it's to the right of 0. And this is the green graph equation, and this is to the left of 0. For this one, here's my function. It's a piecewise function, and I want to find what f of 2 is and f of -5 is. To find f of 2, what I do is I look at the intervals, the 3 intervals, and see which one has 2 in it, or which interval is 2 in. 2 is not less than 1. 2 is between 1 and 3. So I'm going to use this function, and I plug in 2. 2 plus 5 is 7. There it is. 2 plus 5 is 7. To find f of -5, I look in what interval -5 belongs, and that would be here, less than 1. So I could kind of plug in -5, but there's no x to plug it into, and what you have to realize is 3 means it's flat, always 3, forever, for values less than 1. So at -5, your answer is just 3. Now if it was saying, what's f of, say, 5, +5, well, that would be this interval, so it would be -6. So these numbers are actually easier than equations, because all you do is you take that number instead of where, when you had f of 2 here, you actually had to plug it in and find the value. So these are actually easier than the middle one. For question number 5 here, for the first 5 minutes you walked 3 miles per hour. For the next 7 minutes you walked 5 miles per hour. For the last 10 minutes you walk 1 mile per hour. Write a piecewise function if f equals miles per hour and kx is minutes. So f of x is miles per hour. Right, that's the output. Alright, and this is x is minutes. So if I went from 0 to 5, it says right here, for the first 5 minutes I'm 3 miles per hour. So for the first 5 minutes, from 0 to 5, I will have a 3 miles per hour walk. Now for the next 7 minutes, I walk 5 miles per hour. So hopefully you understand, from 5 to 12 would be 7 more minutes. Now the reason there's no line underneath the 5 is because the 5 was included in the first interval. But the 12 isn't going to be included this, because it says for the next 7 minutes. So from 5, not including it, to 7 minutes later, I am walking this rate. So again, just remember the function. 5 represents 5 miles per hour. 3 represents 3 miles per hour. These are actually flat lines because you're walking at that constant rate. And then the last one, it says for the last 10 minutes, walking 1 mile an hour. So from 12, add 10 minutes to that, we're now at 22. And again, the reason you don't have a or equal to there is because 12 is included on this, but we are including 22 because that's the end of the 10 minutes. And you walked 1 mile per hour the whole time. So once again, for the first 5 minutes, for this interval, you're flat at 3 miles per hour. Then for the next 7 minutes, you're flat at 5 miles per hour. Then for the last 10 minutes, you have a 1 mile per hour walk. And this is kind of how you make a piecewise from a sentence. A little bit tough. When I look at this function, I want to know what is y when x is 2. So to find that, I go over here for when x is 2, and I go down about what's my y value. That looks like my y value is about -3. So when x is 2, my y value is -3. But let's think about this. What is x when y is 3? So let's go, okay, look up to, on my graph, let's go up to y is 3. What's my x value? Well, it's right there. So when y is 3, what's your x value? Well, y is 3 right there, which is my x value of 0. So just be careful. When y is 3, we're looking for the x. When we're saying when x is 2, we want to know what the y value is. And you just kind of look at the graph to figure it out. For number 7 here, look at this graph. And from this graph, this is hours and this is money. And we're given 2 points and a line through it. How much are you making an hour? So making an hour would be money per hour. So basically that's saying what's the slope. So to find the slope of this, you need to make 2 coordinates and do the slope formula. So you take this number minus this number right there, and 6 minus 2 right there. And when you do that, you get $5 per hour. So you got to think when they ask that kind of question, that is saying slope because it's dollars per hour is a rate. The question then is, how much did you start with? So how much did you start with? How much money did you start with? I should have put money there. Well, that would be money. So basically what I started with at 0 hours would be that. So, well, I got to figure out the height. So to figure out the height, it's a little bit more complicated. So what we want to do for this particular one is we want to think about the slope. If it's $5 per hour, well, if it's at 2 hours, I'm making $5 every hour, I have to go 2 steps back. So that means I'm going to subtract $5, and then subtract $5 more. So again, if I started with $20, in 2 hours, I go back 2 hours at $5 each, thus it'd be at $10. So I'm going 2 steps back to figure out how much I started with. That kind of is a little bit tricky, but you're using your slope to work its way back. For instance, what if I wanted at 8 hours? Well, I'd add 5 once and one more time, so that'd be 10 bigger, so that'd be 40. You just kind of got to use the rate of change to help you figure it out. All right, I have this table. I want to write an equation for this table. So I have 3 points here. At 6 I get 30, at 9 I get 18, and 11 I get 10. Hopefully you can tell you're decaying, you're shrinking. So you know your slope is going to be -4. To make the equation, what you need is you need this formula. So I need m and b. So I need those 2 pieces. I need m and b. Okay. So I get my m by taking any 2 points. It looks like I took 9, 18 and 6, 30. My 2 coordinates. I took these 2 numbers and subtracted them. So I took 18 minus 30 and 9 minus 6. When I did that, I got a -4, which makes sense because remember, this is shrinking, so I should have a slope that's negative. Now, the problem for this, I know my rate is decreasing by -4, but how did I get 54 here? How do I get my b value? Well, you have to kind of work your way back. What you have to realize is to get to 6th here, I had to subtract 4 6 times. To get to this point, I had to subtract 4 6 times. So if I multiply 6 times -4, I get -24. So that means I subtracted that 24. There is a change from 0. I subtracted something, subtracted 24 to get 30. So what you think basically is you take the 30, you add 24, and that'll give you 54. Because if you deal with this 54, that means I start with this, I subtracted 24 from that, and now my 30, 6 times down. Now that might be confusing. If that is, you could also do it this way. There's the formula. You stick your m in, which is -4. You choose any of the coordinates. I chose the first one. 6 for x, 30 for y. And then I solve for b. There you go, 54. So that's another way of doing it. That's an algebraic way of doing it. Here's logic. You just kind of got to think 6 times back. Okay, so you're basically adding 4 6 times backwards. And that's how I got my 54. You can choose whichever way you want. This one's a little bit more complicated, or more going on. It takes you 10 minutes to walk a mile. That might be what you walk. Now we want to write a function for yourself, with the y-axis being time in minutes, and then graph your function. So that's going to be the tricky part. To make the equation, let's first make the graph. All right. Remember, they said that the y value is minutes, so if this is minutes, this would be miles. So if we graph that at 0 minutes, I'd go 0 miles. But after 1 mile, that would be 10 minutes. I could put a dot there. After 1 mile, I would have been walking 10 minutes. After 2 miles, that would be 20 minutes. Once I get that, I got a line. So the key first is maybe to think of it as putting some points. Again, at 0 miles, I went 0 minutes. But at 1 mile, I went 10 minutes. And again, it says that the y-axis has to be minutes. So be careful on that. Now, what is the equation of this line? Hopefully you notice your slope is 10. That's where I got 10x. And there's no y-intercept, so there's plus nothing. So y equals 10x would be the equation of this line. Now you could have figured that out right off the bat, because 10 minutes, and you could have thought about this equation, but I think it's easier to maybe make the graph and then make the equation. It's your call, whatever makes more sense to you. Now for B, how long will it take for you to walk 4 miles? Well, to walk 4 miles, if I looked at this, 4 miles would be over here, about right there somewhere. And then I'd go up the graph and figure what that is. Now if you look at the trend of this graph, can you tell that that would be 40 minutes? Hopefully. If you also just think about what's going on in the whole problem without thinking about the math and just think logically, you could maybe also figure 40 minutes because you're thinking, oh, 10 minutes per mile, and that's 4 miles, so that would be 40 minutes. Different ways. You could look at the graph, you could use the equation like I did here, or you could just think logically. Now the last one, if you had an hour to walk, what would be your domain and range? First of all, I have to figure out for an hour to walk, an hour would be 60 minutes. That means I'm going up to 60, like way up here. Go over to the graph. So if I had an hour to walk, well, that would be 6 sets of 10. So can you kind of think of that as 6 miles? Again, to figure that out, you could actually put your y value, you could put 60 here and solve it. If you put 60 here and solved it, divide by 10, you get 6. Or however you want to think. But first you have to realize that 60 minutes is an hour. Sorry, that's an important piece to think about. Because, again, this is minutes, not hours. So, anyways, so what we caught on to is this 0 to 6 is my domain, and that's miles. This 0 to 60 is your range because you went from 0 minutes to 60 minutes. So again, this is your range in minutes. This is your domain in miles. Be careful with this, how we're switching. This is the y and the x are backwards. Usually our time is on this axis, so be careful.